Okay, this is a video on lesson 99, z-scores, but this is a specific edition for the Ti83 style. That's not good. 83 instructions, the Ti83 edition. Okay, so if you have a Ti83 style input for the normal CDF, this is going to be very helpful for you. Let's go through the notes real quick. Now, what is a z-score? A value's z-score expresses how many standard deviations it is from the mean. Now, what z is it's x minus mu over sigma, or the value minus the mean over the standard deviation. And you're going to keep 3 decimals where applicable because z-scores need to be very precise. The function and the format is like this. How do we use these z-scores? Well, it's found under second vars on your calculator, and the function looks like this, norm CDF or normal CDF. I'll find out in a second when I go to my calculator. I always forget. But the way that the input goes is they want the z left, right, your left side z value, comma, then your right side z value. And then you can just hit enter, and it should give you a decimal. Now let's fill out a graph before we get started. The amount of time a student's work in any given week is normally distributed, with a mean of 10 hours per week and a standard deviation of 2.2 hours. So the mean is always going to go in the middle. So the mean goes here, that's 10. Oop, forgot to make my marker smaller. Okay, so 10 hours per week goes in the middle. Now I'm going to add, as I go to the right, I'm going to add 2.2. So 12.2, add it again, gets me 14.4, add it again, gets me 16.6. Now, in order to move to the left, I'm going to be subtracting 2.2. It's always the standard deviation that we're adding and subtracting. So minus 2.2 gets me 7.8, minus 2.2 again gets me 5.6, and minus 2.2 again gets me 3.4. So those are the numbers we're going to move forward with. Now, what's important to know, especially if you are on the Ti83, which I assume you are if you're watching this video, is that the z-scores work like this. I'm going to put my z's in red just for you guys. The z here in the middle is 0 because we are 0 standard deviations from the mean. We're actually on the mean. Check that out. Now, if I move 1 standard deviation to the right, my z equals 1. If I move another one to the right, my z equals 2. And here my z equals 3. Because the z-score is just the number of standard deviations that you are from the mean. So I'm 1 standard deviation from the mean, I'm 2, I'm 3. As I move to the left, they're the same thing except for negative. So this is z equals negative 1. Here is z equals negative 2. And over here is z equals negative 3. Now let's do an example of between certain values. What percentage of students work between 8 and 12 hours per week? The way that we're going to answer that question is we're going to use 8 to find our z left. And we're going to use 12 for our z right. Now those are not the z values yet, but we're going to be using those. The reason why is because 8 is right around here, and 12 is right around here. So what I want is I want everything in this region here, but I need to know what this z is, and I need to know what this z is in order to plug them into the calculator. So here's the formula, just a reminder. Z is equal to x minus the mean over, well, it's just a messy fraction line, the standard deviation. So for 8, I'll do this guy in blue. I've got 8 minus the mean, which is 10, over standard deviation, which is 2.2. I'll do this one green. I've got x minus the mean, so 12 minus the mean, which is 10, over the standard deviation, which is 2.2. When I plug these into my calculator, making sure that I put parentheses on the top if I want to do it in one shot, I'm going to get negative 0.909 and positive 0.909. Now, this is the one that corresponds to the left-hand side of this region. This is the one that corresponds to the right-hand side of this region. So I'm going to plug these into my calculator. I'm going to hit second vars, and I'm going to choose the normal CDF between negative 0.909, comma 0.909. And when I hit enter, I'm going to get, let's see, second vars, normal CDF, between negative 0.909, comma 0.909. I'm going to get 0.6366. 0.6366. And what I need to do is move the decimal place twice, so I get 63.66 or 63.7%. So that's how you do between values. Now let's do below a value. If that was a lot, you might want to back up. Watch that part again before you move on. Now, so once again, this is for Ti83 style. Below a value is like, for question number 5, they ask what's the percentage that that work less than 9 hours. So less than 9 hours means we put a cutoff line here on 9, and we are looking for less than. So that's going in this direction. So if I'm working in that direction, I'm going to use a large negative for my z left, because my z left is somewhere over here. Somewhere off there. I'm going to pick a large negative number for that. So let's remember what our z values are. 0, negative 1, negative 2, negative 3. So on that scale, what's a big negative number? Could I say that z left is negative 10? Negative 10 works perfectly, so let's call it negative 10. It could be negative 100, it could be negative 1,000, as long as it's far off in that direction. So let's find z right. Z right is the z value for this point here. So for z right, I'm going to use an actual calculation. We're going to use our given upper bound for the z right. So z is equal to x minus mu over sigma. Our x value is the value in question, which is 9, minus the mean, which is 10, over the standard deviation, which is 2.2. This is going to get me 0.455 when I plug that into the calculator with parentheses on the top. It's going to get me 0.455, negative 0.455. My apologies. Now that's my z right. So I've got z left and I've got z right. So I'm going to go to the normal CDF between negative 1,000, comma, negative 0.455. And let's see what that gets us. Second vars, normal CDF, between negative 1,000, comma, negative 0.455, enter. Gets me 3245 or 3246. So equals 0.3246. I move the decimal place twice, and I get 32.46 or 32.5%. Now last style, above a value. So question 6 asks us about more than 14 hours. More than 14 hours means this region here. So 14 is around here somewhere. More than 14 means we are shading in this direction. So this number right here, this 14, is going to be used to find my z left. My z right is somewhere over here down the line on the right-hand side. So this is my territory for my z right. Now we're going to use the given lower bound for the z left. We're going to use this 14 to find z left. But we're going to choose a large positive number for z right because we don't know where to stop. So let's remember what these numbers are. These numbers are 0, 1, 2, 3. So how many z-scores do you want to go? You want to say z right is, I don't know, 15? 15 works for me. 10 would work. 100 would work. Any of those, right? So let's just say that z right is equal to 15. Now let's calculate our z left. Z left is equal to x minus mu over sigma. Tail's a little long on the sigma. Alright, now let's plug in. X, the value, is 14, minus mu, which is the mean, which is 10, divided by 2.2. Slap some parentheses around this up here. 14 minus 10 divided by 2.2. 14 minus 10 divided by 2.2. That's 1.818. Awesome. So that means that my z left is going to be 1.818. So these are my two z values. I'm going to go to the normal CDF. And I'm going to plug these numbers in. 1.818 and 15. So let me get my calculator. Second vars, normal CDF, 1.818, comma, 15. And now here's the thing, as long as you pick a z value far enough out for the one that's in the tail end, you can actually pick something gigantic, 15,000 I choose. And look, it gets me the same exact number the first time and the second time. Because if you go far enough out, you've already got the answer. Any extra is just overkill. So the good thing is, there's no like wrong answer to pick. So 0.0345. 0.0345. So now let's move that decimal point. 1, 2, 3.45, or round it up, 3.5%. Okay, so that's it for Ti83, folks. I hope that was helpful. Have a good night and good luck.